day. So I'm just going to show you how to do some shading of the Venn diagrams, because you do need to know how to do some of them. The ones in the test are not overly difficult, so you should be okay with doing those. I'll do a tree diagram question, and I've previously uploaded a Venn diagram one with some two-way tables and whatnot. I'll also talk about independent and dependent events as well as mutually exclusive. Other than that, you should be okay for the test. It's not overly difficult, nowhere near like the last topic that we've done. Okay, so for Venn diagrams and shading them, so you've got to remember that this symbol is union, meaning or. Okay, the upside down one is intersection. Apologies for my writing. Which also means and. Okay, so we've got here the probability of A union the complement of B. So the first thing you do when you're shading these sets is you do one way, you shade one way, and then you shade one the other way, and then you decide from there what else you need to shade in. So for the probability of A, I'm going to shade that in red. So for it to be A, it's everything here that I'm doing with vertical red lines. Then we have to do the complement of B. So that means not B. Alright, so it's everything that's not B. I'm going to do it with lines going the other way in yellow. So everything that's not B. So it's all of the outside. Okay, and it's everything that's in this section of A. Okay, because it's a union of the two things, it means it's a combination of the two things. So that means every single thing that you have shaded just now is shaded in completely. Okay, so just with the blue, I'm going to go diagonally so you can see what the entire thing is. So I've just write over here that I did the probability of A with red, and I did the probability of the complement of B with yellow, and the blue is going to be the probability of A union the complement of B. So it's every single thing that we have shaded in just now. Okay, so all of this here, all of the outside, everything here, everything in the middle. Basically, you shade everything except for this half moon of B. Okay? Okay, so now I'm just going to show you how the intersection differs from the union of the same thing. So we've got A and B again, and the probability that we're trying to find is the probability of A intersection the complement of B. So again, I'm going to shade the probability of A in red. So that's all of this. The probability of the complement of B is everything on the outside plus everything that's in here. Whoops, not that middle section. Everything that's here, everything on the outside. Okay, now the difference between the union and the intersection is that the blue part now that I shade is only where they overlap. Okay, so it's only here, all of this section where the two colours overlap. That's how it's a little bit different. Now, if you wanted to, you could go around and erase everything that you've coloured in, okay? Otherwise, I'm okay with you doing it, shading it a bit darker so I can clearly see that it's only that section. Okay, so the next question is on tree diagram. So we've got 4 red counters in a bag and 6 blue. We're drawing out 2 counters, but we're replacing it each time. So we're not taking the blue out and leaving it out or anything like that. We're putting it back in the bag and then drawing the second one. So when we start our tree diagram, remember we start from a point and we go up, and we've got blue or red as our options for the first counter. So you can write up here first counter if you want to. And then for the second counter, if we choose a blue one, we can still choose a red or a blue this time. If we choose a red one, we can still choose a red or a blue this time. And remember, the probability has to be on the branches of the tree, so the probability of selecting a red counter is 4/10, and the probability of choosing a blue counter is 6 out of 10. And again here it's the same. So 4 out of 10, 6 out of 10, 4 out of 10, 6 out of 10. Now remember I said you need to, down the side, you need to list the outcomes. Okay, and it would help to do the probability. So the outcome, we could have blue, red, blue, blue, red, red, or red, blue. And we need to do the probability. So to do the probability of the first one, we multiply, you'll see what I'm circling here, 6 tenths by 4/10. So 6 tenths times 4/10, you'll see 6 over 10 times 4 over 10 is 24 over 100. Okay, so we can do it as 24 over 100. Blue is 6 and 6, so I'll circle it again, 6 tenths and 6 tenths, which would be 36 over 100. Red would be 16 over 100. And red-blue would be 24 over 100 again. Okay, and then you could be asked, what are the chances of getting blue? You would say it would be 36 out of 100 chance. Obviously, you could then simplify to 9 out of 25, but it's up to you how you present your answer. You can present it as a decimal, as a fraction, or a percentage. If you do it as a fraction, it needs to be simplified. It is expected that by year 10 level you can do simplification of fractions without being asked. Okay, so just a reminder, with independent events, the probability of A intersection B is the probability of A times the probability of B. And for mutually exclusive events, so remember, mutually exclusive events are events that cannot happen at the same time. So, for example, to find the probability of A intersection B, it would be 0 because the two things do not occur at the same time. Whereas for mutually exclusive, it has probability of A or B, which is A union B. We do the probability of A plus the probability of B. You do need to know these rules for your test. Have fun studying. We'll go back over a few more things tomorrow in class, and then your test is on Wednesday. Good luck.